Variable acceleration. If an object is experiencing variable acceleration, the acceleration is changing in some way as time progresses. In this circumstance, we may be able to express the acceleration as a function of time. For example, let's suppose the acceleration is 2t take away 3. If the object had this acceleration function, then when t is equal to 0, a would be -3. And I've left units out here, but of course this would be in meters per second squared. When t is 1, a would be -1. When t is 2, a would be 1. If it's possible for us to do this, i.e. express acceleration as a function of time, then we can solve kinematics problems using calculus. Consider that velocity is the rate of change of displacement with respect to time. You know this because if your velocity is greater, you're covering more distance in the same amount of time. Acceleration is the rate of change of velocity with respect to time. We know that differentiation gives us gradients, and that gradients are a rate of change. So velocity is the rate of change of displacement, and therefore the differential. Acceleration is the rate of change of velocity, and therefore the differential. So if we have acceleration, velocity, and displacement like this, then to go from displacement down to acceleration, we differentiate. We differentiate once to get to velocity and a second time to get to acceleration. And so to go the other way, we can integrate because we know that integration is a reverse process. We have previously met the equations for constant acceleration. V equals u plus at and s equals ut plus a half at squared. Of course, there are others, but we will look at these and derive them using calculus.